All right, what do you want to check now?
Well, actually,
we could check a multiple of 3, like 3.
Yes.
It's going to be another sequence.
Okay, so we've already eliminated all the 2 mod 3s.
We need to check the 1 mod 3s and the 0 mod 3s. So.
Okay, so let's start with 0. Let's see what happens.
So we could just check 3.
Okay, so 3.
So 3, it would go 3, 6, 9,
and then
back to 3 again.
Ah,
that's pretty easy.
okay, so 3 works.
3 repeats and then 6 and 9 will repeat.
Okay, so what do you want to check now?
Let's check like 12.
Okay, 12.
12, we'll
15. 18.
20, 21.
24.
27.
Oops, 27.
30. 33. 36. And then that's going to loop up to 6 and go back to our loop.
9, 3, 6.
Yeah.
So
It seems like that the multiples of 3 will wiggle around, but eventually either go to 3, go to 6, or go to 9, and then they'll be stuck in this loop here.
Okay.
Alright.
Very good. So, looking at the beginning at 2 mod 3, we found an argument why it never works.
No.
Looking at 0 mod 3, what do we appear to have stumbled on?
An argument that it works.
It works all the time.
Okay.
Well, maybe not all the time.
Well,
So what do you think is going to happen? The next one we have to check is 39. So what's going to happen?
Well, we're going to go, and I guess either what's going to happen is we're going to hit a square, we're going to hit 81.
Okay. Why is 81 the next one we're going to hit?
Because, well, 81...
Why won't we hit like 49 or 64?
81 is a multiple of 3 squared.
Okay.
So
we will hit 81,
and then we'll hit 9.
and we'll go into here.
In our loop.
Okay, and then we'll have to start at 84. And what are we gonna hit next?
Well,
Beyond we might hit like
What's the next square you're
it's
gonna hit?
12 squared.
Okay.
And then we'll go into this loop and then just loop ourselves
again.
back. Eventually we find our way into this loop.
Okay. So it certainly seems like that's going to be the case. Now, the argument for why that's going to happen involves something that we've talked about just a little bit, called mathematical induction.
Yeah.
But see if you can just sort of sketch the idea for me of why, if you start with a multiple of 3, you're always going to loop. You have the idea now. What's the idea? What's happening here?
So if you start with a multiple of 3 and add 3 to it,
Mm-hmm.
you're eventually going to get a square.
Okay.
And that square is going to be, when you take the square root, that square root is going to be a multiple of 3.
Right.
So then you can just repeat the process and add 3 to that square root. And eventually you're going to get a square.
Uh-huh.
And then you're just back to that. And eventually you're just going to get a square, and then you go back to some other number. And then you're not going to go forever.
Okay, right. That's a critical idea.
Because you're always going to hit a multiple of 3 squared.
Okay. And then what happens when you take that square root?
Well, you go back to some other multiple of 3.
Okay.
And then you go again, and you're going to hit another square here.
Okay. So all you have to prove to finish your idea is that when you take that square root, you end up smaller than where you started.
Well, since...
So when we start with a big number, so notice when we started with 3, the square root came back to 3. So now we're starting with a number bigger than 3. So why do you think when you start with a number bigger than 3 and eventually you hit the square, you come back to a number that's bigger than where you started? Smaller than where you started, sorry. Jeez, I said it wrong. So when you hit that square, you go back to a square root that is smaller than where you started. So when we started at 6, we hit a square, went back to 3. When we started at 12, we hit 36, came back to 6. When we started at 39, we hit 81 and came back to 9.
Well, because 81 squared is... it's a lot closer, or 81, not 81 squared. 81 is a lot closer than 39 squared. So you're going to hit that first. And then when you take the square root is always for positive numbers that we're looking at right here, smaller than the square.
Uh-huh.
So you're going to get smaller than where you started, and you're still going to be a multiple of 3. So you're just going to keep getting smaller and smaller until you get into this loop here.
Okay. What do you think? Why do you think you're going to hit a square? When you hit that square and you take the square root, you go back to smaller than where you started.
Well, so when you take the multiple of 3, so if you take any multiple of 3, and then you add 3, it's gonna end up as a square eventually.
Uh-huh.
And then so that square is gonna happen before you reach the square of the number you started with.
Yeah, why? Yeah?
No.
Yeah, that's the trick. It's the tricky part. So you can think of it like this. You can think of as you walk up the list and you get more and more numbers, you can just start crossing off the ones where you hit a square, or where you arrived at after the square root. So there's the 3. We did the 6. Then we started at 39 and we crossed off the 9. So we're just slowly crossing off the numbers in our list. And we're always behind.
They're your number that you're at right now, like over here.
Yeah, and you can never catch up because these sequences always keep growing because the sub-distance between the squares always keeps growing. So that's sort of the simplest way to explain it.
Right.
It's not super hard to prove. But so now we've covered the cases. 2 mod 3 and 0 mod 3. So what's left?
1 mod 3.
Okay, let's do that.